Greetings all, Joseph Kerski here with you, wearing my kids using geospatial technology and thinking critically and spatially tie. Another manifestation of the changing Earth is landslides. These include mud, rock, a combination of the two, or snow, avalanches. Landslides are naturally occurring events from erosion, soil moisture, earthquakes, or significant rainfall, but are exacerbated by human construction of roads, houses, or from groundwater withdrawal or deforestation. Landslides represent useful, though often tragic, phenomena to investigate both in physical and in social sciences. Skimming the long list of landslides here produces and provides a stark reminder of the serious nature of these phenomena. Lives lost, communities destroyed, property buried. Let's examine several through the lens of spatial thinking using Google Earth. In the investigation, make sure that, under Layers, historical imagery is checked. Enabling this will display a long horizontal bar, allowing you to choose historical imagery. You can extend the bar deeper into the past or toward the present, depending on the area you are studying. Using this Google Earth tool, enter these coordinates: 14 degrees, 34 minutes, 35.3 seconds north, 90 degrees, 29 minutes, 45.8 west. In what country is the map now located? Observe the expanse of mud and soil at this location, a reminder of a past tragic, fatal landslide. Zoom out a bit to see the surrounding area. Is this an urban or rural area? Zoom back in. Make sure you are using the 3D view. How would you characterize the impacted neighborhood? Tick the most appropriate choice below. It was on a steep slope, on a mountain, or in a deep river valley. What do you think? Using historical satellite imagery, examine and determine the year when a landslide occurred here. In that year, heavy rains triggered a major landslide in El Cambre Dos, killing at least 280 people and leaving dozens unaccounted for. The landslide leveled much of the village, covering some areas with 15 meters of earth and debris that you have just observed. How many houses would you estimate were destroyed based on your analysis of the imagery? Less than 10 houses, between 11 and 50 houses, between 51 and 250 houses, or over 250 houses. Has the city rebuilt this area by the time of the latest satellite image available to you? Next, study another landslide that occurred in urban Freetown, Sierra Leone, Africa. Enter these coordinates in Google Earth: 8 degrees, 26 minutes, 11 seconds north, 13 degrees, 13 minutes, 48 seconds west. Examine in particular the satellite images from the beginning to the end of 2017, or compare 2016 to 2018 if 2017 is not available. Which direction did the landslide move from and to? Click on Street View, view photos north of the landslide, such as this one right here. Rotate the photos to see if the slide is still visible in the distance. Why do you suppose that the photos are showing active construction? Continuing your study of the Sierra Leone landslide, access ArcGIS online, arcgis.com. Then use Scene, or 3D Scene. Bypass the initial screen. On the globe that appears, search Y 8.435498 X minus 13.230135. That's the latitude and longitude, north and west. Change the base map to imagery. Rotate the imagery so you are looking from north to south in 3D mode. Then use Measure, Measure Length, and measure from the top of the landslide to the bottom of the valley. Note the 3 components of your length: vertical, horizontal, and along the slope. What is the length of the landslide along the slope? Landslides typically occur on slopes ranging from 10 to 45 degrees, with highest frequency on slopes between 25 and 35 degrees, depending on soil type, vegetation, and recent weather. After creating your measurement in the 3D Scene Viewer, use vertical length as the rise value and horizontal length as the run value to calculate the slope of the landslide. Input your values into omnicalculator.com/math/triangle-slope for the calculation. which uses the Pythagorean theorem, rise divided by run, multiplied by 100 for the percent. What is the slope of the landslide in percent? How does it compare to the most common landslide slope? Enter these coordinates into Google Earth: 48.283 north, 121.847 west. Here, the OSO landslide in Rowan, Washington, USA, killed 43 people in March 2014, following long rainstorms. Excluding landslides caused by volcanic eruptions, earthquakes, or collapses of dams, this was the deadliest single landslide event in the USA's history. What was the primary direction the landslide moved from and to? Examine imagery from 30 April 2014. Examine the land cover here. Which objects falling through the debris were partly why this landslide was so destructive? Did landslide debris cross the Steelhead River? What is a consequence upstream from a landslide that blocks a river? Examine 2012 and 2013 imagery. Note houses here that were completely buried. Examine imagery from 30 April 2006 and at other times to answer. Was this the first time in recent history where landslides have occurred here? Enter these coordinates into Google Earth: 71 degrees, 38 minutes, 24 seconds north, 52 degrees, 19 minutes, 41 seconds west. Zoom out and note that this location lies on the western edge of the Greenland ice cap. What are those white spots in the water? As you examine the historical imagery, you will see marked differences between summer and winter conditions. Even in this remote area, this landslide impacted people. Approximately 260 million tons of rock fell from elevations of 1,000 to 1,400 meters, reaching a speed of 140 kilometers per hour, causing a magnitude 2.3 earthquake in quotes. About 30 million cubic meters of material entered the waters, generating a tsunami that reached 50 meters high, with another wave that destroyed boats at the village of Saquoq, Saqqaq. Use the measure tool above the satellite image in Google Earth to measure the distance from the landslide to Saquoq. What is it? What's that distance? Some landslides move slowly as earth flows. Enter these coordinates into Google Earth: 37 degrees, 59 minutes, 15 seconds north, 107 degrees, 16 minutes, 21 seconds west. This Slumgullion, Slumgullion, earth flow in Colorado, USA, moves about 14 millimeters per day. Even slow-moving earth flows have impact. Number 1, examine the photographs. Here and here. What is happening to the trees here and why? Number 2, the Gunnison River flowing north was blocked by the earth flow hundreds of years ago. What feature south and southwest of the earth flow now occupies the valley of the Gunnison River? That is our study of earth flows, mudslides, avalanches, using spatial thinking and a variety of geospatial technology tools. I hope this was insightful and gets you thinking about not only these, but examine others to analyze the interplay between the physical environment and human populations. Thanks.